Hello, this is Hui. Welcome to watch my video, C++ Programming on Linux. In this short video, we continue to discuss the RabbitMQ in C++. As we know, RabbitMQ uses exchange and queue algorithm to publish and routine the messages. The producer generates a message published to the exchange, and the exchange responsible for routing this message to the different queues, and the consumer pick up the message from the specified queues. In RabbitMQ, the exchange has four types: direct exchange type, Fanout exchange type, topic exchange type, and the headers exchange type. In previous video, we have discussed direct, Fanout, and the topic exchange types. In this short video, we are going to demonstrate how to write a RabbitMQ application in C++ using headers exchange type. Here on the Linux, we just create a program called headers publish.cpp. Headers exchange is designed for routing the message based on the multiple header attributes instead of routing keys. So for headers exchange, there's no routing key required, and the headers attribute format will be the key and the value format. And a special argument named xmatch can have two different values, NA or O, which specify if all the headers must be matched or just one. The default value is the O. A headers exchange is more flexible as it could be integer or hash value of dictionaries. The usage of our demo will be the headers underscore publish. The first argument will be the host and the port number. Second argument will be exchange name, and the third argument will be the queue names. Queue name is optional. If the queue name provided, we will build the routine link between the queue and the exchange. If the queue name not provided, we just publish our messages. Same as the previous video, we first build our connection string. Connection string pattern will be the username, password, @host, port number, and /vhost. In our environment, we created the user called test, password test, and the vhost will be my_vhost. We get our exchange name from command line and argument 2. If argument count equal 4, it means the queue name provided, and we get our queue name from the argument 3. Otherwise, queue name is empty, and the routing key is empty, as the routing key is not required. Same as the previous video, we first instantialize AMQP object, connect to our message queue, and we create our exchange using the AMQP create exchange, which name is from command line. We declare our exchange, which is the headers, and we can set up a few parameters. We just pick up two, auto delete and durable, and we using the set parameter method to set our exchange parameters. We can set up deliver model and the content type and the encoding type into our header using exsetHeader method, same as the previous videos. Because this is a headers exchange, we have to input our header key value from the console. In order to keep the key value pattern, we just create a map object called HDR map, which is a string type, and we start making loop, input our key value header attributes. We promote a help message, start a loop with xmatch, which is a special argument. It can be NA or O. So we loop end with end. So in order making input our key value, we create a vector. We name it header vector. We create a string called a header key value string. Then we start our loop. And so first, we clear our string. We clear our vector. before the loop, we clear our map. We use std getLine to get the input into our header key value string format, like a key colon value format. We split our input into the vector. After we split, our header vector must have two values. So if our header vector size is not equal to, which means input is wrong, so we just go back to continue for input. If after split, the vector 0 and the vector 1 is equal end, then which means end input, we just break end of loop. So if input is okay, and vector 0 is the key equal vector 1, which is the value. So this is the loop for input our key value headers from the consoles. After that, we have to add our input key value into our headers. So we make another for loop. So we make our loop from the header map begin to header map end. In each loop, we set up exchange, set up headers. Set up a header can have a name, value, which name value can be integer, can be string, and there's a third parameter called special. In our class MPQ Exchange class, there's two types of headers, which is the header and the special headers. When we set up the normal headers, which is using the setup header, which is the key and the values. But for set up our header for routine, we need we're using the special, we indicate our is a special. So our will be IT. First is the key, second is the value, and then 1 is for the special headers, which are used for the routine message. So if queue name length greater than 0, which means our queue name provided, same as before, we just set up parameter equals 0, and we create the queue using the create queue method, name the queue2, and we declare queue, which is the name, parameter, and header map inputted from the console. And also we binding our queue, which is exchange name, routine key, and the header maps. And after we declare our queue, and we make another loop, same as example before, we get a message from console and into the string called the message body. If message body equal end, we break end of loop, and after that we just need to exchange publish the message body and the routine keys. So and finish the publish, we clear message body and input another messages. So now we just save our program. We compile our program. So we compile two programs. One is called publish, and the read queue is another program we have introduced in previous video. In this demo, we just compile it. Currently, in our Rabbit message queue, we only have a default exchange, and we don't have any queues created. First, we create our queue using publish. So the usage will be the host address or name, and the port number, and we just code our exchange, HDR exchange, and our queue name, we're using the NA, because our special value could be NA or O. So Canada, Ontario. So in this case, we try to demo the O. So we using our match, which is the O, and we make a country is Canada, province Ontario. So we just into two headers, country equal Canada, province is Ontario, and we just end of input, and we create another queue. Use NA, and the match is NA, and the country is Canada, province is Ontario, and the city is Toronto. Let's go to another terminal to check our queues. We create is NA Canada queue and O Canada Ontario queues. Now we try to publish our message to our header exchange. So in this exchange, we just created the condition. Header is the province Ontario, and the city is North York. So our condition is province Ontario, city is North York. We didn't mention, so it should be the match this NA queues. Now goes to other terminal, check our queue. You can see NA Canada queue had a message being published, and the O match queue is not published because the condition is not O the match. Now let's publish another, and we're using the country is Canada, province is Ontario, city is Toronto. O match, because O match also NA matches. Now let's go back to check our queue. You can see our second message has been routed to both queues, O match and NA matches. Now try to read our queue. So read queue is first is house name and part number. Second is queue. We can have O match and include the headers. So you can see for our O match, the message body, this is the message of O match and NA match, which we published. So for the headers, this is country is Canada and the province is Ontario because it's O match, so it's been published to these queues. Now we read from our NA match queue. You can see we got two messages. First, this is the message Ontario, North York. This is NA match because the match is province equal Ontario, and the second message being published to this queue because the match is country is Canada and the city is Toronto. Any of them match will be published to these queues. Hello, this is Hui. Thanks to watch my video. Hopefully this is useful, enjoyable. It's going to be great to have your feedback.